Welcome student to the third lecture of alcohol, phenol and ether. Today we are doing preparation of alcohol, and the first preparation is from alkyl halide. Now student, this is been omitted from our syllabus, or might be it is given for self-study. That's the reason I'm teaching this. Okay, and you can do according to your requirements, right? So I'm going to teach what is all given in a textbook. The portion which has to be omitted will be later on decided. Okay, so let's start. A very simple one. This preparation we already studied in our previous chapter, right? That is halogen derivatives. Only the thing is that there we have studied in chemical properties, here we are studying in preparation. Okay, so preparation of alcohol from alkyl halide, right? The first is by hydrolysis process. Okay, for example, I take alkyl halide Rx and I treat this with KOH or NOH aqueous. Remember, we have done this. Hydrolysis, heating. What happened? This R is combined to OH to form alcohol ROH, plus this K combined with X to form KX. Simple, right? We can take one example. I take ethyl C2H5Cl, ethyl chloride, treat with KOH. Condition remains same. It results in the formation of C2H5OH, that is ethyl alcohol. This is ethyl alcohol plus KCl. This is ethyl chloride. So very simple. The same can be also done Rx KOH, right? But we do this in the presence of moist, if you remember, moist Ag2O, right? Then also this process can be done and will we get alcohol. Okay, KX, right? So that was the first preparation. Now the second one is by acid catalyzed hydration of alkenes. Now student, this we have studied in 11th standard. Okay, but I will teach you. I'll try to make you understand the mechanism also, the shortcut way to find out the answer. Everything will be taught to you. Okay, understand and understand carefully. Okay, in this there's a two part. In the first part I take symmetrical alkene. Suppose, example, I take ethene. Acid catalyzed hydration means we have to actually hydrate it. Hydrate it means we have to add water. But this water, if I add directly water, the reaction will not happen. That's why we need some acid, because that acid is going to catalyze that reaction. And what acid we are taking is sulfuric acid. What is the formula of sulfuric acid? Sulfuric acid is H2SO4, right? Can I write like this? H H2SO3H, H2SO4. Okay, now when I do this, okay, what happened? See, the bond between hydrogen and oxygen breaks. This part, this H comes to this carbon. Anywhere it can go because it is symmetrical alkene, right? It can go anywhere, student. And this whole part will go to obviously this carbon, right? And the product will be H3C CH2 OSO3H. This will be the product. What will be the name of this, student? What is this? This is ethyl, ETHYL. What is this? This is hydrogen, ethyl hydrogen, and SO4 is left. This is called sulfate, so the name is ethyl hydrogen sulfate, right? Understood this? Now to this ethyl hydrogen sulfate we add water, HOH, okay, and we heat this. What will happen? Understand this whole part. Understand, student, I'm talking about this whole part. This whole part will combine with this H to form sulfuric acid. Means this is going to get removed, OH will get added. When OH get added, the product will be H3C CH2OH. That means ethyl alcohol is obtained. Also this H and this combines to form what? H2SO4. That means at the end of the reaction sulfuric acid is regenerated. Okay, and what is catalyst? Catalyst is one which is the rate of reaction without taking part in the reaction, but actually this catalyst undergo reaction, but at the end it is obtained back. Okay, so we feel like it does not take participation, but actually it do take participation, right? So at the end it is generated, again it is going to combine with ethene, again the whole process will be repeated, right? Clear? So that was when the reaction take place with alkene, and when that alkene is symmetrical. What will happen if the alkene is not symmetrical, that is unsymmetrical alkene? Okay, now what will happen when your alkene is unsymmetrical? Okay, now what is unsymmetrical alkene? Let's see. CH3 CH double bond CH2. Now here across this, on the left hand side of a double bond there's two carbon, on the right side there is only one carbon, so it's unsymmetrical, right? When we have unsymmetrical alkene, now if I have to add sulfuric acid, right, now here the addition can't take place the any way it want, but it will follow some rule. And what is that rule? It will follow Markovnikov rule. What is Markovnikov rule, student? The rule says that the reaction when an unsymmetrical alkene is treated with unsymmetrical reagent, the negative part of the reagent, see this is negative part, this is partially positive, this is partially negative, so the negative part of the reagent will go to that carbon which contain less number of hydrogen. So in this double bonded carbon, this contain less hydrogen, so obviously this is going to come on this carbon, right? So it is going to come on this carbon, and this H is going to attack on this carbon, right? So what will be the product? Product I'm writing here, CH3 CH CH2. Here it will come OSO3H, and this H will come over here to this, so it will become CH3, right? Okay, now it is treated with water, that is hydrolyzed right? So this H and this is going to combine to form sulfuric acid. This OH is going to come over here, so the product will be CH3 CH CH3 OH. This is isopropyl alcohol, and also will get sulfuric acid back, right? Understood? Okay. Now I told you this is the reaction, but if we want to study the mechanism of this, okay, so it takes place in actually 3 steps. Okay, let's talk about the mechanism of this. This mechanism, first step is actually formation of carbocation, right? So first step is formation of carbocation. Okay, now in first step actually water combines with H plus. What is this H plus and where from it is obtained? Understand, student, sulfuric acid or any acid in that matter, they have tendency to give H plus. So the sulfuric acid will liberate H plus, right? HCl will liberate H plus, sulfuric acid will liberate H plus, any acid, right? During the reaction gives H plus. Okay, they are proton donor, so the acid will give H plus. We do understand oxygen is electron rich and this is electron poor, so oxygen is going to give its electron to this hydrogen and it result in the formation of hydronium ion, right? So when I say hydronium ion, I draw the structure like this. This is called hydronium ion, right? Now in this first step, this hydronium ion is going to react or combine with alkene. Let's understand. Suppose I have this hydronium ion. This is treated with alkene. Okay, any alkene for that matter. Now what will happen? Understand. See, understand this. This oxygen is positive, right? That means this oxygen is electron deficient, and oxygen being electron more electronegative in nature, it will not like to be a deficient electron, right? Oxygen cannot hold positive charge. So what is going to do? This is going to take the electrons of this hydrogen. So the electron will come here. This will become plus, right? H plus, and this carbon, right? See, there's a pi bond. This is sigma bond. This is pi bond. So one of the electron, the shifting of this electron pi bond will take to place this carbon, and this carbon is going to take this hydrogen H plus, right? Understand? This or this, any. Okay. So what will we form? It result again in the formation of water, H2O, right? Suppose I say this carbon single bond, right? And if this electron comes over here, this carbon going to take this hydrogen and this H will be formed. And obviously, since this carbon loses its electron or give its electron to this carbon is going to acquire positive charge. Got this, student? So H comes over here and this carbon acquires positive charge. So that was the first step. That is, carbocation is formed. This is the carbocation which is formed or generated, right? In next step, that is step 2, attack of nucleophile. Attack of nucleophile take place. Now let's see how. This carbon, the hydrogen, this is positive, right? Now here, student, water act as a nucleophile. Understand? I draw the structure like this. Oxygen is electron rich, so it acts as a what? It acts as a nucleophile, and this attack on this carbon because this oxygen is electron rich and this carbon is electron poor. So nucleophile attack on this, and the product form will be OH, but now this will become positive. Got that? Oxygen can't remain positive. As a result, this is going to take this electron, right? And this next step will called what? This next step is called deprotonation. Deprotonation. In this step, if this in next step, this H lose away. I again draw it. This is OH, lose here because this is positive. So what will be formed? Here comes H. I didn't draw here H, I'm drawing it now. Here there's H and here there's OH, right? And again H plus is generated. This H plus will again go and combine with water to form hydrogen. This hydrogen will again react with alkene to form carbocation. Again nucleophile is going to attack and ultimately alcohol will be obtained, right? Okay, so this is the mechanism, the whole mechanism. Now student, I also told you, say if in examination MCQs comes something like that, we don't need to understand all the mechanism. I mean, there should be some method by which I can directly, I should be able to give my answer. So how to obtain that answer, I explain to you. Now, this is shortcut. Okay, suppose I have this reactant CH3 double bond CH2. I treat this. Obviously I have to form what? Alcohol, right? So no need to draw that whole complete mechanism, or no need to write that sulfuric acid attacking and the negative part of it. No need to that. Only you have to think that you have to add water in the presence of acid. Just think of this. You have to add water, right? This is shortcut, add water. But how you're going to add water? Very simple. You have to think about Markovnikov Rule, student. Just think of Markovnikov Rule. Then if I think about the Markovnikov Rule, obviously this OH is going to attack on that carbon which is less hydrogen. Obviously this hydrogen has less in fact this has no hydrogen, so least hydrogen, right? So this OH is going to attack on this, and the product obtained will be CH3. This is going to be OH, and here CH3. This is what is the product, student? Can you tell me? This is tertiary butyl alcohol, right? Clear? Okay, so that was the reaction. Okay, now this is the way. You get any question, just do it in a short way. Follow Markovnikov Rule. So remember, what you have to remember, whenever there is an acid catalyzed hydration, add water by Markovnikov Rule. Simple, right? Okay, now moving to the next reaction, that is C. This is hydroboration, oxidation of alkenes. That means again I have to react with alkene to obtain alcohol, right? Now, how to do that hydroboration reaction? And it's an important one, student. You have to understand it, and you have to understand it very well. Okay, now we understand the example, right? I take one example. Okay, CH3CH double bond CH2. This is alkene. I treat this with diborane. What is diborane? Diborane is B2H6. Remember? BH3, they combine. It's a dimer. Understand? BH3, boron hydride. This boron hydride, two molecules combine to form diborane. You might have studied this structure, and that's very important in 11th standard. You have studied this, student. Okay, so this reacts with diborane, right? And diborane, we have to take one single molecule first to understand. Reaction is something different. If I write the reaction, first let me complete the reaction, and then I'll be explaining you that. You have to take 6 mole of this. So in the first you obtained CH3, CH2, CH2 thrice, and here comes boron, this 2 mole, right? And this CH3, CH2, CH3 thrice boron, I have taken 1 mole, and I treat this. This is hydroboration. Actually, this step is hydroboration, right? And now we do oxidation, and in oxidation we treat this with H2O2, hydrogen peroxide, in basic medium, that is OH minus, right? What happens? What the product is formed? Product is this CH3, CH2. I'm sorry, here will be CH2, CH2 OH. Right here 3 moles, so I'll write here 3 with BOH thrice. This is what the reaction. Obviously you have to understand how this happened, and that's very important. We also try to understand the mechanism. Everything we'll understand, and very important, student, this one is really important. Okay, it's really important. That's why 4 star. Now let's understand. I'll start with the one molecule. Okay, CH3. I'm actually trying to explain the mechanism. CH3, CH double bond CH2. Sorry, it's a CH2. If instead of dimer, if I take monomer, so this monomer is going to be like this. Understand? BH3, one molecule. Now student, boron is a metal and it has 3 bonds. So how many electrons are present? 2. 1 bond represents 2 electrons. So 2 electron, 2 electron, 2 electron, total 6 electrons. So when I have 6 electron, that means it is electron deficient, right? This is electron deficient. Understand? This is very important. This is electron deficient. And obviously it will have 1, because boron, if you remember, atomic number is, what is atomic number of boron? Hydrogen, helium, lithium, beryllium, boron. So boron actually have 5 electron, right? So boron has 5 electron. If I write electronic configuration, it will be 1s2, 2s2, 2p1, right? So if I draw this orbital, two electron, okay, here it will 1. If 1 electron jump from here, right? Okay, so suppose 1 electron here comes right here. Now, so 3 unpaired electron, right? and if hydrogen comes, they are going to give one electron to this. So when hydrogen gives one electron, suppose this is electron of hydrogen, right? This get paired. That's how BH3 is formed. But again, this orbital is empty. Understand, student? So if I say this orbital is empty, right, and since it has octet is not complete, so it is electron deficient. If it is electron deficient, obviously it will have a tendency to get that electron, and by getting that electron, it try to complete its octet. So what happened? Let's understand. This is a sigma 1, this is pi bond. We know the pi bond, pi electrons are not very strongly held by the atom, right? So what will happen? So the reaction, to perform this reaction, what is going to happen? There's a migration of this electron to this, right? Now you can also ask me, sir, why the migration not going to take from here to here? It can, but suppose if electron migrate from here to here, the positive charge come on this, right? But if the electron migrate from this carbon to this carbon, the positive is going to come on this carbon. If the positive come on this carbon, this is 1 degree carbocation, right? If comes on this, this is 2 degree carbocation, and we understand, student, 2 degree carbocation are more stable. Although here the carbocation is not going to form. Understand, students, very important. Carbocation is not going to form. Understand this. Okay, but try to understand. So the electron is going to transfer on here, and this electron will be slowly will be going to the orbital of this orbital, or orbital of boron, empty orbital of boron. So when the electron transfer to the empty orbital of boron, boron will be getting negative charge. And student, understand, this is very important again. Boron is metal, right? It will have less tendency to obtain electron. In fact, it wants to, if electron comes, because metal electropositive nature, because it has deficient, it may take the electron, but then very soon it will going to realize that he can't hold that electron, because his tendency is not to take the electron. So what will happen? This boron is going to give this electron to hydrogen, and that's the reason we say it is boron hydride, because this hydrogen is going to acquire that negative charge, and when hydrogen gets negative, right, it is called hydride. Understand? Clear, student? But very important, this giving of electron to this, and this carbon is giving electron to this boron is giving again electron to this hydrogen, and this hydrogen will acquire that minus charge, and this, see, slowly and slowly this is acquired positive charge, right? And slowly and slowly this is acquired negative charge. Because this is positive hydride, H minus is highly unstable. He wants to get stable. He will get stable only if he lose that electron. So this H minus is going to give this electron to this carbon, and this whole process is going to take place simultaneously. Understand, student? It is not going to be like this. Okay, this whole electron going to transfer, it will acquire positive charge, and there is a formation of carbocation. No, this whole process, that the electron from this going to this carbon is giving to this, boron is going to give the hydrogen. This whole process, this whole mechanism is going to take simultaneously, right? It's not step-by-step process, and that's the result. Carbocation is not formed. Understand? Carbocation is not formed, right? So if I try to draw the structure of this, CH3, CH, CH2, B, H, one more H over here. Here the bond is slowly breaking. I put a dotted line. Here the bond is also breaking. I put it in dotted line, right? And again this hydrogen is going to give the electron to this, so I'm going to show it by dotted line. So this whole mechanism take place. So ultimately this electron, this hydride will come and combine over this, right? Okay, so what will be the product? Let's see the product, student. CH3, this H comes over here to form CH2. This is CH2, right? B, H, H. Got that? Okay, that means, first understand, here I take 1 mole of propene. This 1 mole of propene combines with boron and one of the hydrogen moves out. That means here one hydrogen goes away, combines here, and instead of one hydrogen we acquired this group. So if again I react this with what? Again if I react this with CH3 CH double bond CH2, same thing is going to happen. See, again this boron is how many bond? 3 bond. Means again it has how many electrons? 6 electrons. That means again this is electron diffusion. Again it has empty orbital. Again this carbon is going to give this electron to this carbon. Again this carbon is going to put its electron in empty orbital. Again boron is going to give the electron to the hydrogen. Hydrogen will again come to and combine with this. Are you getting? Right. And the product obtained will be what? Let's see. CH3 CH2 CH2 B. If I remove this hydrogen, so again I will get CH2 CH2 CH3. If again I take 1 mole, student, I'm not showing again, but again if I take 1 mole, again this is going to be like this, CH2 CH2 CH3. Got this? That means 3 mole of CH3 CH2 CH2 and 1 B. This is what we have already written here, CH3 thrice and B. So why I've written this 2? Because I've taken 6, not 3. That's the reason I've written it twice. But here I'm taking one boron hydride. Got this? Okay. Now, what happened next? Next is oxidation, student. And oxidation we carried out by H hydrogen peroxide, that is HOOH. Right. Now, I'm not going to explain this in very much detail how this actually what happened. OH minus is also present. This OH minus abstracts the hydrogen from here to form water. This again, this became negative. So this negative again combines on boron. I mean, this whole step increases like this. But to make it simple, how? Let's understand. What I'm doing this, suppose I break it like here. This OH and 2 means we get 2 OH. Similarly, understand, if I break from here, right, I will get 1 OH to boron and 1 OH to this group, right? Same fashion, I break here. 1 OH with this carbon, 1 OH to this boron. Similarly, I break from here, 1 OH to this carbon, right, and 1 OH to the boron. Again, I write here, right. So boron has 3 OH. So what the product will be? Product will be BOH thrice. Can you understand this? Right. And CH2, CH3, CH2, CH2, OH. CH3, CH2, CH2, OH. CH3, CH2, CH2, OH. That means I will get 3 moles of CH3, CH2, CH2, OH. Right. But if I take this what? 3 moles. But if I take twice, why we need to write here 6? Because I have not taken BH3 but B2H6, because normally this exists in this form, right? So that's the reason I have taken 6. Now student, it's very important that we should get this in a monomer form, and because if I take BH3 and they will have tendency to combine with each other to form B2H6. That's the reason we in this we add tetrahydrofuran. So we have to also add tetrahydrofuran. Actually this is a solvent, and this solvent, what is the function of the solvent? The solvent helps so that B2H6 is not formed, in that boron hydride remain in the form of BH3. Okay, so that's the reason this reaction is carried out in THF. Understand? Simple, student? Okay, let's make it more simple, only to get the answer, and that to answer in a single step. Okay, see what the product is formed. Product is 1 degree alcohol, right? Product is what? 1 degree alcohol. Suppose I want to get the answer straight away. Not, I'm not going to, if it is MCQs, we have to give the answer in straight way. No need to write all this mechanism or think about that. So in that case, let's see what we have to, how we have to understand. Suppose CH3, CH double bond CH2, right? This is what, and what is written? It is written like this: B2H6, or they may write BH3, THF. First step. Second step, they write H2O2, OH minus. Suppose this is what is given, and they ask you what is the product. Directly think that you are going to add water. Just add water, student. But add water according to the anti-Markovnikov rule. Understand? Anti-Markovnikov rule. Remember this. You have to just add water, anti-Markovnikov rule. So if I'm going to add water, anti-Markovnikov rule, so this OH minus is going to attack on that carbon which has more hydrogen, right? So which carbon has more hydrogen? Obviously this carbon. So this OH is going to attack on this, and obviously this H is going to attack on this. So here this and here this. See, this is a shortcut. This will directly fetch your answer, right? But you should understand how actually the reaction is taking place. What is this function of B2H6? What is the function of THF? This all you have to understand. Okay, so this H comes over here, this OH comes over here. The final product will be CH3, CH2, CH2OH. That is the final answer. That means I acquire 1 degree alcohol. Okay, so if propane is there, I want 1 degree alcohol, I'm going to do this. I'm going to trade with this. But if it is propane, I want 2 degree alcohol. What I'm going to do? I'm going to do the same reaction by acid catalyzed hydration. That is, there the reaction takes place with what? Markovnikov rule. Got this, student? I hope you understood. This is very important. Right? Okay. So here we completed 3 preparation. We have some more preparation of alcohol, and that we'll be doing next lecture. Right? So for today we stop. Thanks for watching.